access to Excel sheet where all the details of all the sessions of electrical machines would be available. So let me present my screen. So I hope my screen is visible. Okay.
Hello, good evening, sir.
So here it is the first problem. You can see that two loads are connected on the secondary side of the given transformer. We need to estimate some parameters here. So please look at the question and try to find out the way how should we proceed to the solution. Okay. So I hope on through the transformers lecture from the Professor Bhattacharya.
Hello, good evening, sir.
Good evening. Tell me. Yeah, go ahead, please. Hello. Someone was trying to say something. Please go ahead. I am not able to find the name, but anyway. So this is the problem. I hope you are able to see this, and let's try to solve the problem. Okay. From primary side, uh, we have a voltage source and current source. Okay. So some MMF must be created from the primary side, and that would cater the load side. Okay. Is it fine? And for that purpose, we need to find out the value of I2 here. Okay. So
Okay,
how to
sir.
find
I
the
am just trying, sir. Please wait for some time, sir.
okay, okay, yeah, yeah, please. You guys take your time and try to solve on your own, and we will start discussing in 2 3 minutes.
Sir, supply voltage is not given.
No, supply voltage is not given, only primary number of turns and current is given.
Sir, we have to find the voltage per turn, no?
We have to find primary voltage. Do you mean by primary voltage?
Yes, sir. And it is not given, then how to proceed?
Yeah, actually, the uh, value of primary voltage is required in the third part of the same problem. But without that, also you can proceed. You try to recall the concept of MMF balance.
Yeah, N1 I1 equal to N2 I2 plus N3 I3.
Exactly, that is the way to go ahead. right? But again here I3 you don't know, I2 you don't know. Okay, so I3 is required in the next part. So in that case, what to do?
Refer all secondary and tertiary to primary.
Okay, okay. After doing that, we will have the same current. Okay, that's a very good approach. We can definitely consider that approach. So let me draw that equivalent circuit. Okay. Uh, so tell me one thing. Both load, if we try
Yes,
to
sir.
refer towards the primary side, will they be connected in series or parallel?
Series.
Series. Why so?
Because in different primary, secondary, tertiary, current is
Huh.
different. We are making referring impedance to that, so that current will be equal.
Yeah, that is perfect answer. So the reason behind connecting in series, because we are referring to one side, and when we are referring to one side, we are trying to maintain the same current. So that we will do. So let me just uh, do it 75 by 100, okay, into a square. Okay. And other one is 50. So 50 into 75 by 75. So, and this I1 will flow, okay, and there will
Sir,
be
I1
some
is equal to
I1 is 6 ampere here. This I1.
I2 is equal to 4.5 ampere आ रहा है sir.
Okay, you are saying I2 is equal to 1.5 ampere, right?
I3 is equal to 6 ampere.
Verify it.
Sorry, sir. I3 is equal to 6
Huh,
ampere.
I3 is equal to 6 ampere, you are saying. That's great. We will find out. So
V3 and
I1,
V2.
huh, are you telling some value of voltage?
Yes, sir.
How much?
337.5 volt.
337.5 volt. Okay.
Yes, sir.
Okay.
V2.
V2 is equal to, this is Vs. Yeah. How
Yes, sir.
much? V2, how much are
V2
you
is
telling?
450 volt.
450 volt. Okay. Then tell me the V3 as well, if you are telling.
337.5.
Okay, same. Okay. Okay, so for those who are not able to find out the value, we will solve it step by step. Okay. So yeah, so our first approach to find the I2. Okay. So here we can find I1, and I1 is already given. So equivalent circuit, I don't think it will help in finding I2. Will it help?
No, sir.
No. So in that case, we have to fabricate two equations, and then we try to manipulate it, and then we will be able to find out the value of I2, right? So in last lecture also I have given hint for the problem which was given in the current week assignment. So let me deal with that equation. So first equation I can write N1 I1 is equal to N2 I2 plus N3 I3. I hope no one has any objection with this expression. Okay. Now I1 we know, N2 we know, N3 we know. We don't know I2 and I3. Okay. So we don't know I2 and I3. And if somehow we can establish a relationship between I2 and I3, then we can plug in and we can find out by substituting the value of I1. So can we uh, establish a relationship between secondary and tertiary winding MMF?
Yes, sir.
Yeah. So what would be that expression?
Sir,
Using
basically,
transformation
we
ratio,
use
sir.
Is someone telling the expression?
hello.
Uh-huh.
Sir, basically, we have to use here the concept of voltage per turns ratio, like the voltage across the 100 ohm is V2 and voltage across 50 ohm is V3.
Okay.
Then V2,
Uh,
then
V2
V2
by
by
V3 is equal
V3 is equal to 100 by 50, 100 by 75,
75. Right, right.
and V2 is equal to I2 multiplied by 100.
Yeah, correct. Yes, yes. So that's the perfect answer. Can you please tell your name, whoever is speaking?
Sir, Deepak Kumar.
Deepak. Yeah, Deepak, you are very right there. We can establish from the transformation ratio the relationship between V2 and V3, and then we know that V2 is connected across the 100 ohm resistance. So whatever the current will flow, V2 is equal to 100 I2 and V3 is equal to 50 I3. Okay, so let me write it. V2 by V3 is equal to 100 by 75. I hope no one has objection with it. And at the same time, I can write V2 is equal to 100 I2 and V3 is equal to 50 I3. Okay, so now if I equate it, first let me cancel out this 100 and this 100. And now I can write I2 75 I2 or whatever 50 I3 divided by 75. Okay, so I guess I am right. Yeah, and the same expression would have come through the your turns ratio in MMF. So N2 I2 is equal to N3 I3. So either this way or anyway, we have our objective to accomplish. So anyway, so from this expression also we can write 2 by 3 I3. Okay, so I did just rationalize and
Sir,
I yeah, go ahead please.
how did the relation V2 by V3 equal to 100 by 75 came? Both
See
are
V2 by
secondary, no?
yeah. So no, both are secondary. Yeah, but both are different windings. So you can consider it one as a different winding kind of tertiary. Let's suppose they are secondary side of transformer, but it does not necessarily mean that both are secondary windings. Did you get my point? In the
Okay.
one core, you can wound whatever number of windings you want, but it it may be from the visibility, you can observe it is on secondary side, but the windings are different. So all the one load is connected towards the secondary winding, and one load is connected across the tertiary winding. But both are this side, right hand side. So do not get confused with right hand side and secondary side are same. Am I
Okay.
correct? Huh.
Yes.
Okay. So we have found out the relationship between I2 and I3. Okay. Now we will try to plug in the equation 1. So this we can consider it as equation 2, and this was the equation 1. Now N1 is 75. Okay. I1 is given 6, right? And since 6 ampere is RMS, so whatever current we will compute, that will also be RMS value. So N2 we know that is 100, and I2 is, let us assume, to not assume, we have already evaluated, that is 2 by 3 I3 plus N3 I3. N3 is 75, and again I3. So if you solve this expression, you will get 200 by 3 plus 75 I3 is equal to 75 into 6, 450. Now 7, 225, 425 by 3, let us, I2 is equal to 450 into 3. Okay. So, sorry, it is I3, not I2. I hope you didn't get confused. It is I3. And please anyone calculate it for me, the value of I3.
Sir, 3.165.
3.165. Okay, so it is 3.165 ampere. So whoever told me the value of I3 as 6 ampere, apparently it is not correct. So it is 3.165 ampere. Okay, so it might be calculation mistake, or he might have applied different concept. So whoever calculated 6 ampere, are you convinced with 3.165 ampere? Or
Yes, sir.
you, okay, okay,
Absolutely.
great. So we have computed I3 at 3.165 ampere. Now we will plug in the value of I3 into I2. So we know that I2 is 2 by 3 I3. Okay. So from equation second, we can say I2 is equal to 2 by 3 I3. Okay. Now I3 was 450 by 425 into 3. So here we will do cancel out of 3, and 900 by 425. So it will be slightly higher than 2. Please anyone calculate it for me. 2 point how much?
2.11.
2.11. Thanks. So it is 2.11 ampere. So let me rectify it as well. 2.11 ampere. So we are done with the first two parts of the problem. Now the third part is to find out the primary supply voltage. Okay. So which equation should I apply here? Anyone?
Again, sir, voltage per turn, concept of voltage turn between primary
Be-
winding and secondary winding.
Yeah, any winding. Either you can apply between primary and secondary, or primary and tertiary. So here, let's go ahead with primary and secondary. So V1 by N1 is equal to V2 by N2. So from the resistive approach, indirectly we find out the value of voltage in secondary winding, right? V2 is equal to 100 I2. And we know, since we have calculated I2 as, sorry, this is I2. So I2 as 2.11 ampere. So 2.11 into 100, that is V2. And N2 is also 100. So V2 by N2 is again 2.11, and same ratio should be there for V1 by N1. Am I right?
Yes, sir.
Great. So V1 is equal to 2.11 into, I guess 100 is the primary term. No, 75. So
25,
70.
sir.
Yeah. So tell me this value, please. 75
One
into 2.1.
158.25.
158.25 volts. So we have found out the RMS value of the supply voltage. Okay. And that was asked in the problem. So let me rectify this. It has come 158.25. Yeah, next part is interesting. How much power has been delivered by the source? We have to find out. Yeah, guys, help me here. How to find out the power delivered by the source?
V1 into I1.
V1 into I1. Okay. Okay. V1 into I1. That will be indirectly kVA. Okay. So V1 into I1, we will end up with apparent power. And here we are given with real power. So let us try to calculate both ways, and we will see if power factor would be unity, then in that case, our apparent power would be equal to real power. So V1 into I1, if I do V1 RMS into I1 RMS, then V1 we have found out 158.25 into 6. Into 6. So how much is it? Anyone please?
949.5 watt.
949.5. For time being, I am writing it as
Oh,
volt
not
ampere.
watt, sir. It is VA.
Yeah, VA. So for time being, I am writing it VA. Okay. So and
But
other
in
way
the
is to,
question, sir,
yeah. Go ahead.
but in the questions, it is asking a real power in
Real
watt.
power. That's what where we will apply the second concept, and we will try to find out in terms of what. Basically, we will do I2 square R2 plus I3 square R3 because load is connected on the secondary side. Okay. And since we have to assume the transformer as ideal. Okay. So I hope that whatever volt ampere we have obtained, that will remain same. But again, we will verify and then we will come to the conclusion. So I2 was 2 point, let me write it, I2 square R2 plus I3 square R2 is equal to I2 is 2.11 square. You also please calculate side by side. 2.11 square into 100 plus 3.165 square into 50, I guess. Yeah. So please compute it for me. Where did it go? Let's compute this value.
946.07.
946.07 watt. So both values are not matching, both are not equal. So there must be some loss. We might have ignored some losses. Anyway, they are not given, but okay. So are you able to point out any region of mismatching in both the values? Okay. But calculations are correct, right? Both calculations are correct. Let me verify it once.
How much the value of I1, sir? Just
I1
scroll down the
is
screen, sir. I want to see it.
6 amps.
Not 6 ampere, sir.
I1 is
Yeah,
6
yeah, yeah.
ampere.
Yeah, yeah. Thank you, sir.
So that one is correct. 949.5 and 2.11 square into 100. So it is 445.21 plus 3.165 square to 50. So it is 500.86. Yeah, so it is 946.07. That is correct. So, okay, anyway, there might have been some calculation mistake because this transformer is ideal. It means we do not have any core losses, okay, and we do not have any magnetizing inductance. So it means whatever the input power we are applying, that should reflect to output load, whatever power is appearing at the load. So verify it at your own end, and we will discuss further how I think some calculation mistake in calculation of currents might have appeared. So verify it at your own end, and if it will not be resolved, we will discuss it on the next week. Okay. So for time being, we will assume that 949.5 watt. Okay. Now, what is
Sir,
the impedance? Yeah, go ahead, please.
sir, so what is the actual formula for finding the power delivered by the source? Can we use this I
Mm,
square R formula or both that
Uh,
VI into I1 formula?
no, directly it should not be found. Uh, First, you find out how much is the load power and add if there are any losses. So that's problem we have in the later slides. So we will try to find out. We should always move from the load side. First, find out the load power, then try to find out the how much power is getting lost in core losses as well as copper losses.
So first we have to do I square R power calculation
Yes, yes,
and then add the losses. Okay.
yes, yes.
Oh, okay. Okay.
Okay. So let us go ahead. My screen lost. Okay. I think yeah. So, last part, we need to compute the impedance seen by the source.
Hello, sir.
Go ahead.
Sir, I want to say that, sir,
Mm,
in really, I1
mhm,
is what? I1 is nothing but it is a reflected current due
mhm.
to both secondary and tertiary winding,
Okay,
whatever it is drawing.
okay.
So I1 is equal to
Uh-huh.
I2 dash plus I3 dash means
Okay,
phasor term of both, phasor adding
okay.
of both.
Huh.
Then according to that, I can calculate I1, sir. But
Mm-hmm.
both value I am calculating, but sir, both value is come that is coming, and whatever you have calculated, sir, we have calculated both are totally different, sir. How is it, sir?
Okay, let me get your question first. You are saying that to compute I1, sorry, to compute
Is
I2, right? You are
no, sir,
using
no,
the
sir.
phase.
I1 is
Huh,
equal to
let me write it.
I2
Okay.
dash.
Wait. Whatever you are saying, let me write it. So you are
Yes, sir.
saying
I1 is
I1 is
equal to
I2
I2
dash
dash plus
plus
I3.
I3 dash.
Yes.
Okay.
Sir, here summation means phasor sum. Then you have
Summation
to,
means phasor sum. Yes. Phasor.
yes.
Okay.
Then
Okay.
from this concept, I want to calculate the magnitude of I1.
Okay.
Yes,
So
sir. Please, sir, help me, sir.
okay. So if you let me see. See, I1 could be equal to I2 dash or I3 dash because see, we connected here both resistance in series, right? So whatever I1 is flowing, same value of current will flow as I2 dash through the secondary resistance and here I3 dash, and both are same. So you can equate with I1 is equal to I2 dash or equal to I3 dash. Did you get my point?
Sir, both
I1.
tertiary and secondary winding, is it connected in series?
Mm-hmm. We
Both
are
are different
it is
winding, no, sir.
they are not connected in series. We are simplifying our calculation by connecting them in series.
Okay,
You
okay.
got my point? We are
Yes, sir.
Sir,
simplifying our yeah. Huh.
sir, when we find the equivalent circuit of this circuit transformer connection, we will
Uh-huh.
get the secondary and secondary resistances. That is 100 ohm and 50 ohm in parallel.
Uh-huh.
No, it will be in parallel.
Uh-huh. You are saying both 50 and 100 ohms should be in parallel.
Yes, because their currents through those resistances are not equal. This will be possible only if the I1 current is going and it is split apart into I2 and I3. That is, it should go to two branches. One branch will
Yeah.
have 100 ohm
Fif-
and other
fif- huh.
branch will have 50 ohm.
50
So it
ohm,
will
right?
be connected in parallel.
Okay, so
The equivalent circuit will
uh,
have parallel connection of 100 ohm and 50 ohm.
okay, so you mean that this circuit is wrong according to you?
Yes, sir.
Okay, okay. See, uh, if we are referring towards here, what we did here, we just referred the secondary resistance or load to primary side, right? And this tertiary we also referred it to primary side. Okay,
Yes.
that's what we did. And when we are referring, we want to maintain the same current. You got my point? We do not
Okay.
want different current. We want to maintain the same current. And for that purpose, intentionally, we referred with the multiplication of a square of transformation ratio, and we connected all of them in series, so such that I1 should be equal to I2 dash. I2 dash is nothing but uh, N1 by N2 I1. Okay. So,
Okay.
and similarly, I3 is also normalized according to the primary winding, and the resistance has also been referred. So, if in this circuit, to find the current, it has become very easy, current and voltage and everything. So that's the use of our equivalent circuit. Okay. And what
Okay.
you are saying that we have to apply KCL, we should apply to parallel branches of load. That also logically correct, but that could not be applied here. So that will not benefit
Sir,
us in any way.
sir,
Yeah.
according to that, if my friend is saying that both are in parallel because
Mm-hmm.
the current flowing through the both resistor are not same. It is
Mm-hmm.
not meaning, no, sir, for the parallel. Parallel means the potential at terminal of both element should be same.
Yeah.
Therefore, there should not be equal, no, sir. Then how can I say that it is a it is in parallel? If it is in not in series, then definitely
Yeah.
we should
Yeah.
not do it in parallel, no,
So
sir.
yeah, that's another logic to explain it. You connect both in parallel, but in that case, would you able to maintain the equal voltage among the both windings?
This is the main concept for paralleling the elements, sir.
Yeah. You brought the things from very basics, and that is very uh, good approach to visualize. You see all the way to solve the problem, and you try to find out the way. Would it be feasible to connect both in parallel? So we connected both of them in series because of so and so regions. Now, uh, after the session, you try connecting both in parallel, and you see whether it is feasible or not. If it will be feasible, then we can go ahead with that. We can discuss it in next session. Is that fine? Whoever has concern with parallel winding, it was Deepak or who?
Okay.
Okay, Atul. So
Hello,
Atul, you verified. Yeah, Deepak, go ahead.
hello,
Yeah, Deepak.
sir. Actually, this is a multi-winding transformer. We cannot transfer from secondary to primary because if we do this, then the answer will come wrong.
Okay, we cannot transfer what?
It is a multiple winding
Hmm. Yeah.
transformer. We cannot transfer from
Huh.
secondary to primary in this case.
Okay, so whatever we did by transforming or referring, that should not happen according to you.
Sir, here is a only apply the concept of voltage turns ratio because voltage turns ratio is a applicable for all times.
Okay, I got it. But why can't you refer it? That I don't understand. Is there any basic
Because sir, it
principle?
is a multi-winding transformer.
Okay, so what does it say? Multi-winding transformer?
Yes, sir.
No, what does it say, multi-winding transformer? You tell me.
Multi-winding means it has a multiple winding instead of two winding.
Yeah, so is there any concept that you cannot use referring in multi-winding transformer? Have you studied somewhere?
Sir, actually, if you see, I2 will be different, and as well as I3 will also different, and V2 also different, and V3 also different, right?
They are different. We have calculated here.
So we cannot connect in series as well as not parallel because they have a different current and voltage.
Yeah, that different currents and voltage, I agree. See, we are connected in series, we have connected both elements in series, but we are maintaining current which are not exactly secondary or tertiary currents. Here, they are I2 dash and I3 dash. If you establish a relationship between I1 and I2 dash and I1 and I3 dash, are both of them same or not?
Not, sir, not.
No, sir. No,
Never.
sir.
I1 and I3
Never.
dash are not same.
Yes,
No,
sir. Because
because turns ratio is also different, right?
Yeah,
because
yeah.
sir, just I want to say that, sir. Just it's my
Yeah.
concept, opinion, sir. Please, sir, help me if there will be any problem, sir. Because
Okay, okay, go ahead.
sir, if I2 is flowing through the
Mm-hmm.
secondary winding, okay,
Mm-hmm.
due to which primary winding will also draw some extra current as I2 dash. Okay, this is
Yes.
the one concept.
Okay.
And let us consider if I3 is flowing in the secondary winding through the
Mm-hmm.
secondary winding, due to
Mm-hmm.
which due to which primary winding also gets some extra current, drawn some extra current from the supply as I3 dash.
Yes.
Means in this
I.
circuit, in this case, my primary winding drawing two different type of extra current. First is I2 dash and second is I3 dash. And
Okay.
summation of both will be the total current which what you have drawn from the supply for the primary
Okay.
winding.
Okay.
According to this concept, the total current uh,
Mm-hmm.
drawn by the primary winding is
Mm-hmm.
equal to the
Mm-hmm.
extra current from extra current drawn from the primary winding due to secondary winding and that of tertiary winding.
Okay. So basically, what are you saying? You are saying this statement, right?
Yes, sir. Yes, sir.
Yeah. So
Sir,
Deepak,
this is
distinguish
correct.
yourself first. Yeah. This is
Yes, sir.
correct.
I have calculated this. I have calculated this relationship, and this is going to correct. I1 is coming 6 ampere as they have given.
Okay. I1 is okay. According to this expression, how much I1 is coming? Let us verify. Okay.
Yes, yes. This will be good ideas.
Hmm. I1 is equal to this I2 is correct, Deepak.
Yes, sir.
Yes,
2.11.
sir.
I2 is correct and I3 is also correct, right?
Sir, we have to find out I2 dash, not I2.
Okay, sorry.
And we should do the phasor summation, sir. That
Okay.
means using
Yes,
the
yes, yes. No,
Sri
no.
Aadhaar.
But
This is
but
correct.
but but both are resistive loads,
Same.
so there is no need. Yeah. So I2 dash 2.11
Yeah,
into
yeah. Yes, absolutely.
75. Sorry, into 100 by 75.
Yes,
Into
sir.
100 by 75 plus I3 we have calculated as 3.165. So 3.165 into 75 by 75. So Please calculate it for me. First term, since second term is as it is. Uh, 3, 4, 2.11 into 4 by 3. By 3.
2.81.
2.81 plus 3.165. So that is close to 6 ampere, 5.98.
5.97833.
Yes. So, okay.
5.98.
Sir, approximate.
Approximately.
Yes, sir. Yes, sir.
Yeah. So I think,
Sir, I want to see just the value of V1, sir, please. Yeah. Thank you, sir.
yeah, see this.
Yes, sir. Current power drawn by the supply, sorry, delivered by the primary winding, same, sir, is coming. Approximately same.
With this I1 value, 5.98.
Yes, sir. Yes, sir. 5.97.
Okay, with 5.97 into 6. So it is coming 949, right? How much?
946.335.
946.335. So V1 is 158.25
Into 5.98.
into 5 into 5.98. It
Yes,
will
sir.
be
946.335.
946.335. Okay, so but since in the problem itself I1 is given 6 ampere, then how to consider this 5.98? That's one thing. And other thing, we will simplify this in 3 circuits, and then we will see what should be the concept. Since here a conflict of concepts are there, okay, not calculations. So we will see the concepts first. Okay, we will try
Yes, sir.
to handle it. So see, it is the primary winding we have. Okay, V1 and some current is flowing, I1. Okay, let us suppose this is secondary winding with the load. Sorry. With the load of how much? 100 ohm or something. 100 ohm. Okay, and it is connected to tertiary winding, since it should be here and here.
Sir, below this secondary winding, we should draw, no, sir, it.
Below or besides, nothing. That's why I indicated dot. It will not create any problem.
Okay, sir. Thank you, sir.
So secondary has 50 ohm, and here we have I2 and I3. But I think if I will place it below, then it will be less confusing. Okay. Is it fine now?
Yeah, absolutely, sir. Thank you, sir.
Okay. So yeah, now we will see. So we will try to find equivalent. So 100, we will try to refer N1, N2, and N3. Okay, so if I will transfer 100 on this side, 100 into N1 by N2 square, Okay, and this I1 was flowing, and this I2 will also flow here. I2 dash, that will be equal to I2 into N2 by N1. Am I correct till this point?
Yes, sir.
Yeah. Now the thing is how to refer 50 ohm. Okay. So 50 ohm will be referred to the primary side, and this current, whatever I3. Yeah. So let me refer it first. Then 50 into N1 by N3 square, and whatever I3 should flow here, it should be N3 by N1. Now, if I3 into N3 by N1 will be equal to I1, then it will be in series, otherwise it will be in parallel, right? If I am saying I3 into N3 by N1 is equal to I1, okay, according to this condition, it will be in series, otherwise it will be in parallel. Let me write it. Otherwise, do you agree with this statement, Deepak? Deepak, are you there? Okay. Anyone else who has any
Yeah.
doubt regarding this? Okay.
No, sir. This one is correct.
Okay. So we have found out I3, right? I3 is
Yes.
I3 is 3.165. I3 is equal to 3.165 into N3 is 7, 75, 75. Yeah. So this is 3.165. So since it is not equal to I1, it means it cannot be connected in series. Okay. So we have drawn here a conclusion that if this expression is not holding true, then they will be in parallel. So apparently they should connect in parallel, not in series. Okay. Now
Yes, sir.
I think I also did that mistake of
Utility
connecting only
go.
one
Hanggang
series.
dumating ba?
Sorry. Yeah. So, but I wanted to go through the very basic how or why it should be in parallel or series or not. So that's why that person who told that uh, we should connect in parallel, I think some other guy told. So I asked him to go and verify with the voltage expression. If the voltages are same, then they can be connected in parallel, otherwise not in series. So this discussion leads to a very fruitful and important conclusions that they should not be connected in series. Okay, so they are connected in parallel.
So both will connected in parallel.
Yeah, both loads, if we are referring towards primary side, both should be connected in parallel. We verified with the expression, so it came out that we should connect them in parallel. Okay.
Sir, current.
Current is the same. I1 is equal to I2 dash plus I3 dash. Since I3 dash here we computed, right? I3 dash here we computed, and it is not coming equal to I1. So I1 is equal to I2 dash plus I3 dash.
Please go through the from 20,
Okay. So
5 minutes before, sir. Please, sir.
please go
Just,
through what? Sorry.
sir,
Hello.
please tell me whatever you have done in previous 5 minutes.
Okay. See, so what I did is I connected both the windings and I explored both the possibility whether they will be able to connect in series or parallel. Okay. So initially, see here we connected both the load in series and we found out some values. However, some values are correct because of MMF balance. And but the discussion led to whether can we connect them in series or not, or it should be in parallel. To verify that, what I did, I referred both the load towards primary side and both the currents towards the primary side, and I tried to equalize the current of tertiary reflected to primary to the primary uh, actual primary current. Okay, so that came out not to be equal. Okay, otherwise, if since this I3 dash would have come out equal to I1, then we could have connected in series. But it came out other way. I3 dash came out to be 3.165. Okay, so it is way less than 6 ampere. It means both are not same. So hence we concluded with the our statement that both windings of load side cannot be computed in series. They will be
In
in parallel.
primary side, yes, sir.
Yeah,
But
yeah.
for the parallel, we should manage not, sir, equal to the, there should be equal voltage at the both node, sir.
Yeah, so now if we want to verify the voltage, we
Yeah.
will do that as well. Okay. So let us suppose this is V2 and this is V3. And V2 should be I2 dash into R2 dash, and V3 should be I3 dash into R3 dash. Okay.
Yes, sir,
Do you,
yes.
okay. So if you agree with that, V2 dash is equal to I2 dash R2 is equal to should be equal to V3 dash I3 dash R3. Now
R3
I3
dash, no,
dash,
sir.
I3 R2 dash and R3 dash. Yeah. So R2 dash we have computed, I guess. Anyway, R2 dash is R2 dash will be 100 into 75 by 100 square. Okay.
Yes, sir.
Yeah. Where did it go? Huh. So I2, sorry, R2 dash is 100 into 75 by 100 square. Okay. R3 dash is 50 into 75 by 75 square. So it will be 50. Please compute R2 dash for me. And in the meanwhile, I3 dash we have computed, that is 3.165, and I2 dash is equal to N1 I1 divided by N2, and N1 is 75 by 100 into 6. Okay, so 3 by 4, 18 by 4, 18 by 4 is 4.5. I2 dash is 4.5 ampere. So we just need the value of R2 dash. We will find
56.25, sir.
56.25 ohm. Okay. Now I will do I2 dash into R2 dash. So 4.5 into 56.25. This is I2 dash into R2 dash is equal to I3 dash is 3.165 into R3 dash, that is 50. So please tell me both of them are same or not.
No, sir. Clearly, you
Both
can
of
see that.
yeah, both of them are not same. So it means apparently we cannot, but there might be some calculation mistake. Otherwise, they should be equal, right?
No, sir. For this transformer, it should not be equal because load is different.
But
Then
voltage per turn ratio both should be same, no?
but but if it should not be equal, then how are we connecting them in parallel?
Yeah, this is the
Sir,
main.
Sir, we cannot transfer this in this transformer because this is a multiple like it has a three winding, not two. So we cannot
Okay.
use the concept of MMF balancing because there is a possibility of the one current, the one MMF is balancing to the another and another two is balancing. So there is another possibility as well.
No, see, here only primary winding is catering the MMF requirement of both the loads. Okay, secondary and tertiary. So
Yeah.
Yes, sir.
one thing is certain that N1 I1 should be equal to N2 I2 plus N3 I3. That cannot be questioned here.
Hmm.
Now
Yes,
the
sir.
next
This is correct.
huh, now the next thing we are we are trying to refer to the primary side. Okay, both the windings. And the question
Hmm.
arrived as you read the question, we can connect in parallel. So apparently we did simplified and current came out to be I1 is equal to I2 dash plus I3 dash. If I1 is equal to I2 dash plus I3 dash is the condition, then both should be in parallel. Otherwise, how could it be connected?
Yes, sir. Yes, sir. You are correct. But sir, please see the circuit.
It is the circuit here.
sir,
No,
the
sir.
final equation,
Given why the question? Given in
Okay, okay,
question.
sir,
okay. Yeah, this
sir,
one.
the final equation for power consumed by load equal to I2 dash
Hmm.
square R2 dash plus I3 dash square R3 dash.
Yes.
And when we do it, we are getting 946.07 watt. Okay,
Hmm. Yeah.
946.07 watt. That's true
Yeah.
now.
That's true. Yeah, 946.07 watt when we are doing I2 square R2 plus I3 square R3.
No. I2 dash square R2 dash plus I3 dash square R3 dash.
Uh, that way also it can be true, but I2 square R2 plus I3 square R3, that will also lead to this value 946.07. If you are doing I2 square R2 dash, it means you are referring both one time. Like I2 dash is equal to I2 into N2 by N1 and R2 dash is R2 into N1 by N2 a square. So you are ending up with the same expression. So both should lead to same exact value.
Oh,
Did
yes.
you get
Okay.
my point?
Okay.
Huh. Yeah.
I did it by making the equivalent circuit, parallel equivalent circuit. First,
So
I made the parallel equivalent circuit.
that will also give you the same value. Yeah, it is fine. Then you are about to say something else, or is it that?
Sir, hello.
Go ahead, Deepak.
Now, sir, please see the circuit.
Yeah.
Okay. Now, here you can observe every like both secondary winding have different turns, right?
Yes, yes.
Yes.
And they have a different load.
Different word. Agreed.
So, whatever the value of I3 and I2,
Mm-hmm.
the voltage cannot be same, right?
Voltage cannot be same. Yeah, volt per turn should be
I
same. Voltage cannot be same. Yeah.
Yes, voltage per turn should be same because if you calculate voltage per turn in primary side, that will same as secondary of both winding.
Okay, okay. I got your point. I got your point. So you mean to say only voltage per turns will be same, voltage will not be same. Okay.
Yeah,
Yes,
yeah.
Yeah,
yes.
This
that's
is the
true.
also reason.
Yeah, that's true. Okay. So it means apparently we cannot draw equivalent circuit of this transformer.
Yes, we cannot draw because it is not two winding transformer, and if the each winding have same turns, then we can draw.
But
Okay,
sir, but
continue.
in if there is three winding transformer and any person have no idea about the uh, basic concept of voltage per turns, because it
Okay,
is basically come from the referring of the circuit from one side to secondary side using the transformation ratio. It is
yeah,
not
yeah.
the thing. But how
Uh-huh.
can we calculate if that there will be no any reference? Then how can we refer one in theory more than two winding transformer?
Yeah,
How
that
can
Hello.
is
we
what
approach that?
I think here it should be like that. Well, so where is the equivalent circuit?
There should be a some.
It should be uh, V2 dash either or V3 dash, that we will check. Okay, so V2 dash. Okay, and it should also be equal to primary voltage, no?
Yes, sir.
So, okay, let me see. The value we computed V2 dash, V2 dash, yeah, I2 dash into R2 dash. This one, 56.25 into 4.5, okay, into N1 by N2. So N1 is 75 by 100. Please compute it for me. With this, multiply 75 by 100.
189.84 375
189.84.
375. Yeah.
Uh, okay. And this value into 75 by 75. So it should be same. So how much does it
150.
come? 150?
About
Around
150, not
150.
No, it will be more than 150. You
yeah,
let
about
let
150 we can say.
let me
158.25.
158.25. Okay. So, have you guys gone through the
Please, yeah, yeah.
uh, equivalent
Please
circuit
stay with
lectures?
this screen, sir.
Yeah, I am there. Yeah.
Sorry, sir. Be in previous state, sir. That was good.
Uh, this?
I want to see the question, sir.
Okay. Yeah.
Yeah. Perfect. Okay, thank you, sir.
Okay, so what I will do, I will come up with some idea of how to draw equivalent circuit of when we have windings with more than two, we have transformer with more than two windings. Okay, so there must be some way. If not, then we should find one. But till that time, try to balance it out with voltage and current, and the by the way we found all the answers. You could go ahead, but for the equivalent circuit, there should be somewhere what I feel personally, and I will come up with something. Okay, then. I hope there are no issues regarding the values of initial four parts, right? Is it? Okay, so we will go ahead with the last part and we will try to evaluate the impedance which is seen from the source side. So that will nothing but we will refer this 100 ohm and this 50 ohm. Okay, so with the 100 ohm we will when we refer so 100 into 75 by 100 square, okay, plus this 50 into 75 by 75. So is this fine? If you compute this, you will get the value of impedance or not? Anyone? Please go ahead.
26.47.
Sir, I want to say a good thing, sir.
Please say.
Both are both, sir, the voltage.
Mm-hmm.
Sir, please, move with original question, sir. I want to say
Okay.
good thing, sir, which we for
Uh,
us.
uh,
Sir, I want to say that, sir, a voltage
mm-hmm.
transferred, okay,
Uh,
a voltage due to transformation of the secondary winding to the primary winding, and the
mm-hmm.
voltage due to transformation of this tertiary winding to the primary winding, both are equal, then I can
Okay.
calculate that both should be in parallel. Just
Okay.
I want to conclude that this voltage is equal to the primary voltage or not. If the both are three are same, three voltages are same, then all three things will be connected in parallel. This
Yeah.
sir,
So
if you,
yeah,
sir, I want to say
that by
that, sir,
uh, yeah. Go ahead. Go
if
ahead.
we if you transfer the secondary winding, okay, to the primary
Mm-hmm.
winding, then
Mm-hmm.
I calculate, sir, voltage is equal to I2 dash into R2 dash, okay.
Okay.
And if I transfer this tertiary winding to the primary winding, then I calculate I3 dash into R3 dash. And
Okay.
when we conclude, then both are same, sir.
Okay. Both are coming same for you.
Yes, sir, both are same. You can also check it, sir.
I
Please,
checked
sir.
it here. Both did not come same as you guys only told me the values. So
No, sir. Please, again, sir, go through this. We will confirm. Definitely
okay.
do it,
So
sir.
see
Yes.
I2 dash R2 dash. We did it here, right?
I2 dash is equal to I2 upon A. Okay.
Okay.
How much was I2, sir? According to this question, 2.11 was I2.
Okay. Let me
2 point,
let me.
sir, please write us anywhere else.
Okay. Okay. Wait a second.
Please write with
Wait
me, sir.
wait a second. Wait a second. I2 dash was
Into
2.11 into 100 by 7
sorry, sir.
sorry
Mhm. Yeah.
100 by 75, yeah, 100
Yeah,
by
yeah.
75.
Then it is
So
equal to 211 upon 75. 211 upon 75.
yeah, so how much is it?
Okay, sir. I will tell you, sir. 211
uh,
upon,
I2 dash somebody okay,
yes,
I
sir.
calculated it.
2.813. Sir, I will calculate in last, sir. Let,
Okay,
okay.
okay, okay,
2.81,
2.183.
sir, not 18.
Okay, 813.
813. And R2 dash is equal to
Mm-hmm.
R2 into,
Yeah, that we have computed. Is it correct? 56.25
no,
R2 dash?
sir.
Oh,
Yeah,
not
yeah.
correct. Oh, okay, 100 into 75 by
And
100 square, right?
25 upon 100 square. Yeah.
Okay, so how much it came?
I will just tell you, sir. 100 into
Someone told me this 56.25. I don't know.
56.25.
Yeah, it is written there, 56.25 ohm.
Yes, sir. And now we will conclude with this. Okay. Go with it, sir. Also, I3 dash is equal to I3 upon A. How much was I3, sir? There was 3.165 as I3.
3.165, and it will remain same, right?
Remains same because the winding are
Uh,
same. Number of
yeah,
turns are same. And R3
yeah.
dash is equal to
Uh,
R3 dash is equal to same
50,
50 ohm.
50 in 50 ohm. Yeah,
Yeah.
yeah.
Now we will multiply with above those equation
Oh,
and below those equation.
okay. I think mismatch of I2 dash has happened because
After
I2
this,
dash I wrote 4.5. Yeah, so I3 dash
after this,
into after this, how much is it coming?
Uh,
no,
I want to
no,
say
3
again,
dash
sir.
square R, I3 dash square R3.
Okay, I
158.25.
sorry. I
Sorry,
didn't
I
get
want to
any of
calculate.
you.
I am
Please,
calculating the voltage.
please say one by one. Okay, I am getting confused here.
Yes, sir. I3 dash into R3 dash
I3 dash into R3 dash.
is equal to
Hmm,
158.25.
158.25. Okay, volt. Now I2
Now,
dash R2 dash.
okay, just I'm saying, sir, 2.1. 158.23.
Oh, means nearly same.
Exactly same, sir. When we can,
Means
if I
exactly
you can
same.
write, sir.
But how did it
Because
come
there is a
different
3
earlier?
2.81 like so on this, sir.
Okay. So
This
yeah,
is not
now
perfect decimal number, okay.
okay. So if it is the case, then both will be connected in parallel,
Hello.
right? Yeah,
Yes, sir. Both
Excuse me, sir.
resistor and cursory will be
yeah. Go ahead.
connected in parallel.
Wait. Deepak wants to say
Hello.
something. Go Deepak.
Sir, I3 is 3.165, right?
I3 is 3.165. Yes, correct.
I3 dash also 3.165, right?
Huh.
Then multiply by 50.
Hmm.
It will come, it will nearly equal, but sir, we can connect in parallel.
Not in nearly. It is exactly, sir. I want to say, sir. Please go with this last uh,
Okay.
statement, sir. I2 dash into R2 dash is equal to. Please
Okay.
remove it,
So
sir. 158.23.
okay. So apparently, as of now, see, I'm writing as you guys are telling. Okay. So for now, if both are coming equal, and from my observation, it should come equal because there should not be anything that we cannot draw the equivalent circuit of any transformer. There must be a way to draw equivalent circuit of a transformer. But anyway, I have relied on your calculator since I am out right now. I am taking from the remote location. But in the next session, I will come up with the calculation and justification for the parallel connection. And if at that time you guys do not get convinced, then we will find out some other way. But yeah, it is a good discussion and we will keep it on. Okay. So is it fine for both of you? I use Deepak and one more guy was telling something I3 square R3 plus I2 square R2. Who are that? Please tell me your name.
Yeah, sir, that is the power consumed by the load.
Atul, you were saying. So that is correct. Yeah, that is since it is an
Uh,
ideal transformer. So
and
whatever power, huh,
since since it is an ideal transformer, the power consumed by the load will be equal to the power delivered by the source. There will be no
yeah,
power loss. Okay.
yes,
So so its final answer is 946.07 watt. That's okay, sir.
946.07 watt. Yeah, it should be that
Point
value.
07.
Yeah. Hmm. Okay. So I think it's
Okay.
time to move ahead. And since we have spent a lot of time on this problem, But anyway, it was a very good discussion. It was brainstorming for all of you, I hope. At least it was for me. And yeah, I will clarify the value. And from after observing so much, I can say both should be in parallel. But anyway, I will come up with the concrete proof and all. Okay, so I hope, should I move on? Anyone has any
Yes.
objection?
Yes, sir.
Okay,
Sure, sir.
okay. Thanks a lot. Did it go? Huh. So see here also two transformers are connected side by side in this problem. I hope you are able to see. Let me increase the brightness here. Yeah. So here we have to find out in the first part, this is the first part, how much is the maximum value of the supply voltage that can be connected without exceeding the ratings of any of the transformers.
Dead bolt.
Sorry, how much?
Dead bolt.
10, 10 volt you are saying? 110.
No, sir. 100 bolt.
Okay, 100 volt you are saying. Okay.
Yes, sir.
Okay, so 100 volt had been support from Deepak. Anyone else want to say something?
One ten. Sorry, 110.
110 volt is from Atul,
No,
right?
no, sir. I use.
Ayush, yeah. Ayush. Okay, so there are two possibilities only, either 110 or 100. So the maximum voltage that we have to apply, which should not exceed the rating of any of the transformers. So let us, the rating of the transformer is 110 of the first transformer, and transformer 2 is 100, right, of secondary side. So if to find out the Vs, we will try to do that transformation thing. So here, let's suppose it is 100 volt, and here it is 1000 volt. Okay. Now, the turns ratio of the transformer 1 is 110 by 1100. Okay. So till now, there is no problem of rating because both are same till this junction. Now, here we have 1000 volt. Okay. But we can use this transformation ratio 110 by 1100 because terms are not going to change, just the value of voltage we have to maintain. So now 1000 into 110 by 1100, if we do, then it should be 10 and it will come out to be 100 volt. Okay, so Ayush, are you agreeing with 100 volt or not? Well, what is
Sir,
the logic behind your
sir.
110 volt?
Uh,
Go ahead.
where you have written, sir, plus minus 1000 volt,
Hmm.
there should be 1100 volt in sir, because the transformer, it is the transformer 1.
No, this 1000 by 100 is for transformer 2.
Yeah,
See, and this
and
1000
the
volt is reflected on the secondary of transformer 1, since both of them are in parallel, right? Both winding.
but sir, in transformer there was a 1100 volt in sir, as a secondary volt.
That is the ratio of turns and that is the rating, but we should not violate the rating. Since, see, if we have two options, here, yeah, you are very correct. That's why this question is very tricky. here the question has provided that 110 by 1100. Okay, but from the transformer to it is getting reflected 1000. So which value should we you consider after taking the this protection into the account? Which rating you will choose
one
as an
1000, sir, but
V1
sorry,
in
yeah,
calculation,
V1 by V2.
in
V1.
calculation it is the while, sir.
Yeah, from question you can directly write it as, let me from
For
question
the
you
first
can
transformer, for the
from
first transformer, the
yes,
voltage ratio is 110 by 11000,
yeah,
110 by 1100.
yeah, that is correct.
Then for the next primary of the second transformer, if it is
Mhm,
above 1000 voltage, it will get
mhm.
damaged.
Yes, yes,
Then only maximum 1000 up to 1000 it should be come in the primary of the second transformer.
yeah, yeah,
Uh,
that's the
this
logic
implies
here.
since the
Yeah,
since there is no winding resistance, the secondary of the secondary of the first transformer will have the same voltage as the primary of second transformer.
correct.
Then
Did you get it,
110 by
Ayush?
okay, okay,
Yeah,
sir, you can.
yeah, Atul, you can go ahead. Atul, go ahead. You are explaining very well. Yeah.
And 110 by 1100 equal to let
Mm-hmm.
the voltage supply be x by 1000.
Mm-hmm.
Then we will get 100 volt. 100
Yeah,
volt is the answer.
yeah. So see, when the uh, ratings, as far as ratings are concerned, we should always consider when two things are connected in parallel. We should always consider the lower value. As an electrical engineer, if you apply any value of voltage or current, you should always maintain, as in, power electronics also, you will learn how much the value of gate pulse or how much the value of this voltage should be applied across the switch to get it turned on. So always we take the minimum value, so that if the minimum value is able to turn it on, or the minimum value is able to maintain our circuit in safety condition, then there is no need of going with higher value, right? So if 1100 and 1000 volt both are connected in parallel, so it's in your hand. With if you keep the primary winding of transformer 2 as 1100, it will exceed the rating of transformer 2, and then it will be in vulnerable condition and it may get damaged.
Yeah, sir, that is the problem because it is also avoiding the KVL equation, sir.
No. Here we do not have concern of KVL. Here we have concern of safety. Here we are not applying KVL or KCL. Here it's in your hand. You can apply 1100 on the secondary of transformer 1, and that will be reflected to the primary of transformer 2. That is for sure. But that 1100 voltage it will not be able to handle or withstand.
Yeah, sir, because 1100 volt is not good for the transformer 2.
Huh.
Exactly.
It
If
will
we
exceed
connect
the
this,
rating.
then
Yeah.
transformer will to be burnt, according to
Yeah.
me.
Yeah.
But
That's that's correct. Yeah.
yes,
Go ahead.
sir, because if why then why it is mentioned in the question, sir, like this
It
controversial matter?
because yeah, it wants to judge. It wants to judge your judgment. Okay. How would you select the rating of, as you are going to be an electrical engineer, since you are doing electrical engineering? So how will you pass your judgment? What kind of voltage in such scenario you will go ahead with? So that is for that basic aptitude kind of question, is it?
Yeah, sir, yeah, exactly.
Yeah.
Then, sir, after concluding this, we should neglect the thing which is harmful for the transformer in ideal
Yes.
transformer.
Yeah. Or with any circuit, you should try to maintain below the rated value. Right. Ratings are provided such that you should not exceed that rating.
Yes, sir. Yeah,
Yeah.
absolutely, sir.
And
Because
second,
if you
huh, yeah.
connect, sir, 1100, okay,
Mm-hmm.
let us consider in some case, I have considered 1100, then
Mm-hmm.
there is no value of there is transformer 2, which is connected in cascade with transformer 1.
Mm-hmm.
There will be no meaning. That means question will be uh, wrong according to a student whenever it do like this.
Yeah, you can say in that way. You can say, but here the intention of question is to uh, judge your decision making process. How will you decide which rating you should go ahead with? That's the thing about it. Okay, so I hope first part is clear. Now regarding the second part,
Okay, thank you,
how
sir.
much? Yeah, thank you. So how much
Sir,
is the maximum?
screen is
Yeah,
not visible, sir.
not visible. Let me. Ah, okay. Just 1 minute, please wait.
Yeah, perfect, sir.
Is it visible now?
Yeah, perfect. Okay, thank you,
Ah,
sir.
yeah, thanks. So how much is the maximum value of the supply current that can be drawn without exceeding the ratings of any of the transformers? Okay. So how to proceed with this part? Let's see.
25.5.
75.5 ampere of the maximum supply current you are saying? It should be
Sir,
provided.
25. No, sir,
25.
24.5. 24.5.
Okay. Okay then. Hmm. So how to proceed for this 24.5? Or wait for just a couple of seconds. Does anyone has any other answer or any other thing to say before Deepak will explain this? Okay, Deepak, go ahead.
Sir, since they have given
Yeah.
ratings of each transformer,
Mm-hmm.
and
Go ahead.
the voltage of both sides,
Mm-hmm.
right?
Right.
So we can find out what is the primary current
Right.
of first transformer.
Yes. This is the expression, right?
So, sir, IS will come 24.5, right,
From this expression.
sir?
Okay.
And now
Huh.
we will calculate the primary current per second transformer, which has the kVA rating of 3 kVA.
Huh. Wait. I 2 3 kVA divided by 1000, right?
Yes, sir,
Yeah.
1000.
So it will be 3 ampere.
Yes,
Okay.
Both
sir.
are the
Now,
minimum current.
Now, when we refer the IS into the secondary using the turn ratio or transformer ratio, whatever you want to choose,
Mm-hmm. Yeah,
then that current will
24.5.
come.
Just a second. 24.5 into this primary is 110 divided by 1100, and it should come out to be how much?
So
To
something 2.5
2.2
like.
2.45 ampere. Yeah.
Yes, sir. Yes, sir.
2.45
It is a
ampere.
within the limit. Yes, sir. Yes, sir.
2.45 ampere. Yeah. So again, we ended up with two different values, and we will have to choose the lower one, right?
Yes, sir.
Yeah. So we have two options, either 3 ampere or 2.45 ampere, and as you think the winding this rating of transformer 2, since here we did we took transformer ratio of 110 divided by 1100, and if you choose from this point 1000 by 100, then you will be able to get it in terms of 3 ampere. So it should not be such that it should exceed the limit. So I every time we will try to avoid the maximum value, whichever is coming from the two different expressions, and we should go ahead with the minima of both the
So,
value. So here 2.45 we will consider, which is going at this winding, and now we will refer to the primary side, which was already there. So you will end up with 24.5 ampere, because 2.45 into 110 divided by 1100, that will be 24.5 ampere. Now, if there is any doubt, you can go ahead.
Yes, sir. It is the maximum amount of current which can flow through the
We,
primary winding of the first transformer.
yes, we should flow without exceeding the ratings of any of the transformers. So, to
sir,
according to the demand of the problem, we have to choose the minimum of both the values. Yeah,
sir,
go ahead.
but we can't apply 110 volt to the supply voltage Vs. The maximum supply voltage that can be given for Vs equal to 100 volt, no?
100 volt. Yes, yes, you are correct. But
Uh,
see,
then
turns are
then
not
the maximum
changing.
okay. Then the maximum supply voltage equal to 2.7 into 10 cube by 100
110.
100. Then that is
Why we are taking?
2700 by 100. Then it will become 27 ampere, no?
Yeah, in that case it will be 27 ampere, but we are computing current. In that condition, we have to go to the minimum value of the current. Okay, so the minimum value of current, how will you find? From which expression? 110 or this? Sorry, by which one? Let me highlight it. By this one or this one. So you have to pick appropriately which transformer ratio will give you the minimum value of current. You got my point?
Yes,
In
sir.
first,
Okay.
you are correct. In first part, we found out the minimum value of voltage to be 100 volt. Okay. Now here we are trying to find out the minimum value of current, and that will come after you will divide with the maximum value of the voltage or the rating of the transformer. Because anyway, if you apply the voltage less than the rating, then you are going to get the higher
So
value of current, right?
it
Since your
is it is
transformer
the in the question is asked it is in
huh,
the question is asked maximum value of current, no?
maximum value of current that can be drawn without
Uh,
exceeding the rating of any of the transformer.
uh, then
Huh.
how?
So rating in terms of current, if you will find from the see, if we have transformer one as a 110 rated value, right? Now, if you reduce that value of current, less than 100, sorry, you reduce the value of that magnitude of the voltage lesser than 110, then your source current will getting increased and increased, right? There will be many cases where you can apply voltage less than the rated voltage. Did you get this statement?
Yes.
Huh. So in that case, if you apply less than the rated voltage, you are bound to get the higher value of current.
Yeah,
But
yeah,
we
exactly.
want,
Because
huh.
yes, lower
So
voltage side higher
hmm,
current to maintain the
yeah.
KVA cycle.
So in that case, when you are trying to find out the current, you must ensure that you have applied the rated voltage. Otherwise, what if you reduce the voltage value from the rated value, you will get higher current. So in that case, it may create problem from the current side. Did you get my point, Atul?
Yes.
Are you convinced with that statement?
Yes. Sir, can you explain once more?
Yeah. So when we are given with rated voltage and rated current, okay, and
Ah,
you are trying to find out from the transformer's rating, you must always operate the expression with the rated value of voltage. See, if you reduce this rated value of voltage, let me highlight it. If you reduce this value, your IS will keep increasing and increasing. But
ah,
we want the maximum value which the circuit can withstand, and that will be the rated current, right?
okay. Okay.
So rated current will come if you divide the kVA by rated voltage.
Ah, yes.
Hmm. So we have to maintain the rated current in that or in those cases. So we should go with the higher or rated value of the voltage of the transformer. I can
Okay.
understand it is contradictory from the first part, but it is the way to compute the rated values.
Okay. Okay.
Now, in third part, how much is the maximum value of kVA that can be transmitted to the load without exceeding the ratings of any of the transformer? Any idea? You have already computed the rated voltage and rated current, so you can compute kVA, right?
Sir, 2.45 kVA.
मगर एक पॉइंट ज्यादा
2.4.
करने वाला है प्लीज है
So 2.45, let me write 2.45 kVA. Since we have found out the maximum value of supply voltage without exceeding the rating of the transformers, as well as maximum value of the supply current without exceeding the ratings of any of the transformers. So we just have to multiply both of them, and that will be the maximum value of the kVA that can be transferred, right? So
Yeah.
apparently, let me compute 24.5 into 100. So it will be 2.45 kVA as it was told by Deepak. And see, this kVA rating is lesser than the rating of the transformer which was initially given in the problem, 2.7 kVA. So this 2.7 kVA it could have withstand, but this the voltage and current corresponding to 2.7 kVA, this 1100 and 110, that could not be the feasible for some cases. Hence, we are going with minimum of both the values, and we are ending up with the 2.45 kVA. Right? Is it fine?
Yes.
Okay.
Yeah, because it is good for both transformer. But
Yes. Yes.
in previous case, whatever you were saying, sir, which is only for first transformer, not good for second transformer. And in
Yeah.
question is mentioned that which not exceeding the rating of any of the transformer.
Yeah. See, in first part, we computed voltage as 100 volt, but the rating of that transformer is 110 volt. That is because of the reason we are securing the primary winding of transformer 2. So because of safety region of primary winding of second transformer 2, we are maintaining it at 100 volt. Since primary transformer is getting underutilized at 100 volt, but again, we have to connect at that value to ensure the safety of primary winding of transformer 2. Now, in the second part, we could have gone ahead with 30 ampere, right? But we restricted that current to 24.5 ampere. Why? Because the safety of the transformer 1, we have to be concerned with the safety of transformer 1. That's why we reduced the value of current to 24.5 ampere. So again, in this case, transformer 2 is getting underutilized, but we have to endure that and we have to go ahead with this condition. And finally, we have to be happy with 2.45 kVA of the rating of the transformer. And yeah, that should be the answer of this problem. And uh, yeah, we are going to move on the last part of this problem. But any final question on above three parts?
Sir,
Go ahead, please.
sir, there is no
Okay.
question.
Okay, so we will go ahead. In last part, we have connected the maximum allowable supply voltage Vs. Under this condition, estimate the minimum value of the load resistance that can be connected
Sir,
without
4.08 ohm.
4.08 ohm. Okay, so I will ask the region from you as well.
Yes,
Before
sir.
that,
I can
anyone else?
now tell.
Uh, but before that, I will ask to hear if there are any different answers for this.
Sir, same.
Okay, same. Then, if everyone else is agreeing, then we can hear the reasoning of Ayush. Okay, Ayush, go ahead.
Yes, sir. Yeah. Exactly, sir. Because, sir, in all conclusion, after all
Mm-hmm.
conclusion, we conclude that the maximum supply voltage, okay, is this,
Mm-hmm.
and the maximum available current is this. Then
Yes.
we have to choose the such load.
Huh.
Okay, we have to choose such load that
Mm-hmm.
do not
Mm-hmm.
exceed the maximum uh, allowable current. That should not be exceed the maximum allowable current. What we have concluded, because I have
Yes.
concluded that the maximum current is 24.5
Yes.
ampere. Okay,
Hmm.
we according to that we have to conclude. We have to connect such load across the transformer so
Mm-hmm.
that so that the current flowing through the load should not
Mm-hmm.
exceed the this rated value of the current. That's why we have to simple divide uh, rated voltage with rated current, which I have included not through the questions ratings.
Okay. Yeah, that's correct. Yeah, that's correct. So, what expression did you use to find out this 4.08 ohm? This
Yes, sir.
transformer.
Just I have simply take the ratio of both voltage and current in terms of what you have
Okay.
concluded as
Okay.
a
So you
rating.
let me. Okay. So you did 2.45 since we need current here, I3. So 2.45
Voltage first
in
current. Sir.
into 1000 divided by 100, right? This is the current.
Yeah, you are right, sir.
So this
I'm
is
not.
again this 24.5 ampere, and this voltage is 100, right? Voltage is 100, this V2.
Yes, sir.
So V2 is 100 volt. Now RL we can compute V2 by I3. So I have denoted it with I3. You can denote with any other parameter. So V2 is 100 by 24.5. So it will lead to 4.08 ohm. Or other way is to you could have done V2 square, KVA square by KVA. And since you know the KVA 2.45, okay, into 10.3. And V2 square anyway is 100. So 100 square divided by 2.45 into 10 to the power 3. So that would have also led to the same answer, 4.08 ohm. Okay, so any way which is convenient to you, you can go ahead with it. I just showed you two different formulas of the same parameter. Okay,
Yes,
so
sir.
I hope
Please
this. Yeah.
tell us, sir.
Sorry, what did you
In
just say?
which way we have calculated, sir? What are the different uh, for approach?
I think when you are given with the ratings in terms of KVA, you just go ahead with RL as or resistance as or impedance basically. Let me, since here we are dealing with only resistance, so that's why I use resistance. If you are asked impedance, impedance is nothing but voltage square by volt ampere, whatever you are using. So we have already 2.45 kVA, so I use that kVA, and voltage also is given. So that will give you the total impedance of that side of transformer or any circuit for pulses. Okay, got it? Ayush?
Yes, sir. Okay, okay. Thank you, sir.
Yeah. So I hope it was the last part, and I hope you got benefited from this session. So I am at the verge of ending. If you have any final question, just go ahead with it.
Sir,
Yeah, please go.
sir, can you explain the how third question? How much is the maximum value of KVA that must be
Yeah.
transmitted to the
So,
load?
so maximum value of kVA means we have to multiply with voltage and current, and that maximum allowable voltage we have calculated from the first part and second part, right?
Yeah.
So here 2.45, we just multiplied the voltage we obtained from the first part, that was 100 volt, and that with current we obtained in the second part, that was 24.5 amperes. So we just multiplied both and we got 2.45 kVA. Okay.
Okay, okay.
Okay.
And how the current second one?
Current of second one, how did we find? That's what you're asking.
Ah,
Okay. So current we found from that. See, here we had this two expressions, 2.7 kVA or 3 kVA, right? In two parts, we had 2.7 kVA and 3 kVA, and
yeah.
we applied this value of this formula of current in primary transformer, 2.7 kVA divided by 110. But we had option of doing it with 100 as well, as we discussed that with 100 volt you will exceed the rating of the transformer. That's why we had to go with 110 volt. Okay.
Okay,
So
okay.
100, because of 110 volt, we were able to obtain the value of 24.5 ampere, and that we multiplied at last.
Okay.
Okay. Then. So I hope all of you are convinced, and I will verify the first problem, and we will clarify in the next session. Okay. So this
Thank
is
you,
all
sir.
from my side. Thank you very much for attending. Thank you very much. Have a great night. Bye bye.
Hello.
Yeah, Deepak, go ahead.
Sir, actually, I am preparing for GATE 2024. So, sir, I want to know from you how I should prepare because only 6 months is remaining.
Okay, so
Sir,
for gate, you told gate, right?
Yes, sir. Yes, sir. Gate 2024.
Okay, Gate 2024. So, see, from next week, Gate session will be started from NPTEL side. So that you must start attending from next session. Sorry, from next week. And for other things, you just message me or call me. Okay, anytime. Tomorrow or it's better you call me on Wednesday. I will write my number in chat box so we can
Sure,
discuss
sir.
over
Sure.
call or
Monica,
mail.
vama cuma selalu down
Sure, sir.
Yeah, so this is my number. I am typing in chat box. Anyone has any concern on any question, you can call or message me on this number, and we can talk. Okay.
Okay, absolutely, sir. Thank you, sir.
Yeah, thank you very much again. Bye bye.
Sir,
Yeah.
but I cannot get your number, sir.
You did not get chat box?
Hello, sir.
Yeah. Didn't you get the number in
Sir,
chat box?
but the chat box is not opening in my device, sir. So please tell me
Okay.
verbally.
Okay. So, okay, just a second. Yeah, it is